Hello students, continuing our further MCQs on electric charges and fields. In this video, we will solve from 11th to 20th problem. So 11th one, if you take, two spheres are carrying charges 6 microcoulomb and 9 microcoulomb, separated by distance d, experiences a force of F. So there are two spheres. First is having charge 6 microcoulomb. Second one is having charge 9 microcoulomb. Distance between them is d. And the force of repulsion between them is F. So I can say F is proportional to 6 into 9. When a charge of minus 3 microcoulomb is given to both spheres, so I am adding minus 3. So add minus 3 to both. So if you add minus 3, now first sphere will have a charge of 3 microcoulomb, second will have a charge of 6 microcoulomb, and kept at same distance, so this distance remains the same. So again here you will have F is proportional to 3 into 6. So then the new force is, so I will take this as F dash. Now take the ratio or divide, you will have F dash by F is equal to 3 into 6 divided by 6 into 9. So if you simplify, you will have 1 by 3, cross multiply, you will have F dash is equal to F by 3. F dash is equal to F by 3. So option D is the answer. 12th one. An electron of mass m, charge E, falls through a distance h meters in a uniform electric field. The time of fall is as asked. So distance he has given, has asked us to find the time. So second formula we will be using from motion in a straight line. S is equal to ut plus half at square. So again initial velocity is 0. So if I take S is equal to half, A is QE by M t square. Now substitute. In place of S, you substitute it as H. So here only I will write H. So T will get, if I cross multiply, 2H into M divided by Q into E is equal to T square. Now here charge is electron E. So in place of Q I will substitute it as E and I will take root. So T square is equal to 2Hm by small e into capital E. So we will have T is equal to under root of 2Hm by E into E. Now check the option. So option A is the answer. Option A is the answer. Clear students? Next, 13th one. Two spheres of electric charge plus 2 nanocoulomb and minus 8 nanocoulomb are placed at a distance d apart. So there are two spheres. First sphere is having charge 2 nanocoulomb. Second sphere is having charge minus 8 nanocoulomb. The distance between these two is d. If they are allowed to touch each other, what will be the new distance between them to get a repulsive force of same magnitude? So force of same magnitude means in both case force is the same, distance is different. So here I will take F proportional to 2 into 8 divided by t square. So if they are allowed to touch, when you touch both spheres there is a redistribution of charge. So 2 minus 8 is equal to minus 6. So if again they are placed at same distance, so sorry, not at same distance but at a certain distance so that force is the same. So when they are separated, First one will have a charge of minus 3 nanocoulomb. Second one will also have a charge of minus 3 nanocoulomb. Distance between these two I will take r, which we are required to find. R you are required to find. So as force is same, again here I will keep F. He has told magnitude, so sign neglect it. 3 into 3. Distance I have taken it as r square. Now if I take ratio, in both cases force is same, so equating both expressions. So 2 into 8 divided by d square is equal to 3 into 3 divided by r square. So I will have r square is equal to 9d square divided by 16. Take root, you will have r is equal to 3d divided by 4. R is equal to 3d by 4. So option C is the answer. Option C is the answer. Next, 4 into 10 raised to 14 electrons are removed from a neutral metal sphere of diameter. So this much electrons he has removed from a sphere. Diameter is 20, means radius is equal to 10 centimeter. The magnitude of electric field at a distance of 20 centimeters from its center. So here capital R I will take as 10. So this R is 20, means point is outside the sphere. So electric field E is given by 1 by 4 pi epsilon naught Q divided by R square, where R is 20 centimeters. Instead of directly giving Q, he has given number of electrons removed. So I will write this as 1 by 4 pi epsilon naught. Q is N into E by R square. Now substitute all the values. So 9 into 10 raised to 9. Number of electrons 4 into 10 raised to 10. Electron 1.6 into 10 raised to minus 19 divided by r square. R is 20 centimeters. So 20 into 10 raised to minus 2 bracket square. So centimeters I have converted it into meters. So now simplify. You will get the magnitude of electric field. So numerator if I take, so 9, if I take a numerator 9 into 4 into 1.6 into power, if I simplify 10 raised to 9 into 10 raised to 10, 19. So you will have 10 raised to 0. So plus 19 minus 19 gets cancelled. So denominator if you simplify, so here just I will write it as 1, or here I will write it as 10 raised to 0. So students will get confused. So divided by 20 means 2 into 10 raised to minus 1. So I can write it as 4 into 10 raised to minus 2 if I square it. 4 into 10 raised to minus 2. So now simplify. You will have, so 4 gets cancelled. So 10 raised to minus 2, if it comes to the numerator, it will be plus 1.6 into 9. 16 9s are 144, means you will have 14.4 into 10 raised to 2. Now shift the point, you will have answer 1440. So option D is the answer. Option D is the answer. Clear students? Next, 3-point charges plus 2q plus 2q and minus 4q are placed at corners ABC of an equilateral triangle ABC of side x. The magnitude of electric dipole moment of the system. Electric dipole moment of the system we are required to find. So 3 charges he has given. So I will take this as plus 2q plus 2q at corners, here plus 2q, here plus 2q, here minus 4q, I will divide it as minus 2q minus 2q. Side he has given it as x. Now here along the base you will have one dipole that is directed from negative to positive. So if I take a dipole moment of this, that is P1, charge into distance you will have 2q into x. Similarly, one will be along this. So again charge into distance, I will take this as P2, 2q into x. As it is equilateral triangle, angle is 60. Now if you observe, P1 is equal to P2 and angle is 60 degree and theta is equal to 60 degree. So directly you can write, which I have taught you. So P net moment will be equal to, if it is 60 and both are equal, then it will be root 3 into P1 or root 3 into P2. So root 3 into 2q into x. Root 3 into 2q into x. So if you check the option, answer A. Option A is the answer. Next one, 16th. A certain charge 2q is divided first into two parts q1 and q2. Later the charges are placed at a certain distance. If the force of interaction between two charges is maximum. So for force to be maximum, the both charges in which you have divided should be equal. Means in this problem, 2q is divided into two parts q1 and q2. So for force to be maximum, for F max, q1 will be equal to q2 and that will be half of the initial charge, that is 2q by 2. So you can say q1 is equal to q2 and that is equal to q. Now find the ratio. Then he has asked ratio q by q1. So this is q. q1 is also equal to q. So both get cancelled. You will have ratio as 1. So option A is the answer. Option A is the answer. Next one. An infinite long thin straight wire has uniform charge density 1 by 4 into 10 raised to minus 2, means he has given lambda. Electric field at a distance of 20 centimeters as answer. So electric field due to a thin long wire is given by lambda divided by 2 pi epsilon naught into r. Now substitute the values and simplify. So r he has given, lambda is given. So I will modify this one. So I will write it as 2 lambda divided by 4 pi epsilon naught into r, so that it will be easy to simplify. So this I will write it as 1 by 4 pi epsilon naught into 2 lambda divided by r. So now substitute the values. So 1 by 4 pi epsilon naught is 9 into 10 raised to 9 into 2 into lambda is 1 by 4 into 10 raised to minus 2. R is 20 centimeters, means 1 by 20 into 10 raised to minus 2. I am converting it into meters. 20 into 10 raised to minus 2. Now simplify, you will have the answer. So this gets cancelled. So 2, 10. So you will have 9 by 4. If I cancel this 10, 10 raised to 9 will become 10 raised to 8. So 9 by 4 is 2.4 to the 8. 1 remains, means 2.25 into 10 raised to 8 Newton per coulomb. So check the options. So 2.25 into 10 raised to 8. So option A is our answer. So option A is our answer. Clear, friends? Next, 18th. A point charge q is placed at the corner of a cube of side A. Electric flux through phase A, B, C, D. So, if you observe here A, B, C, D, this phase is touching this charge. So, if a phase is touching the charge, then the flux through that phase will be 0. Flux through that phase will be 0. So, directly option C is our answer. Option C is the answer. 19th, the electric field lines on the left have twice the separation as those on the right. Electric field lines on the left have twice the separation as those on the right. So here separation is, if it is R, here the separation is 2R. If the magnitude of electric field at A is, so electric field at A is 40 volt per meter, you are required to find force on charge at B. So first, if I take formula of electric field, we know that it is magnitude wise mod of dV by dx, means E is inversely proportional to dx, separation between these. So as separation increases, as dx increases, E value decreases. E value decreases. Or you can say closer the lines, electric field is stronger. Farther the lines, electric field is weaker. So as the distance is doubled, electric field gets hard. Therefore, EA he has given it as 40 volt per meter. Therefore, electric field at B will be half of this 20 volt per meter. Now force on charge at B. So F at B will be equal to Q into E, that is Q into EB. Charge is 20 microcoulomb, 20 into 10 raised to minus 6 into electric field is 20. So this is 400 into 10 raised to minus 6, or you can say 4 into 10 raised to minus 4. Check the options. So option C is the answer. 4 into 10 raised to minus 4 is the answer. Lastly, 20th. Nature of Gaussian surface in electrostatic is. So as you know, so Gaussian surface in electrostatics, it is a vector quantity. You know that phi is equal to E dot ds. So this is vector, even ds is vector, as it is a dot product, flux is scalar. So flux is scalar, but electric field and area are vector. So Gaussian surface is a vector quantity. Clear, students? So again, further MCQs we'll see in next video.